What is up, YouTube? We are going to build this G23LH head kit engine. I'm making this video separate from the little mini bike video because I don't want that video to be very long. Anywho, let's go over the way I like to assemble engines, and we will get this head kit engine underway. I went ahead, and anytime I build an engine, every bolt gets ran through a die and every hole gets tapped. So that way, no matter what you're doing, the screws go in and you don't hit a false bottom and you don't get a false sense of torque. I have actually lost engines due to the fact that like red Loctite or something had, not on this engine specifically, but like jet skis and stuff, like a piece of red Loctite would actually be still down to threads, and you put a bolt in there and you would torque it against it. You'd knock it out and it'd go to the bottom, and the bolt would torque against squishing that piece of junk at the bottom, and you get a false sense of torque, and you got a cylinder that lifts. And you have a cylinder that lifts, that means you have a cylinder that can pull air. When you pull air, you run lean, and jet skis are super prone for pre-detonation. Skadoosh, it blew up. I did order some new stuff for this. Some of this stuff is going to be used. Oh man. A brand new OEM bearing. I think it's OEM. It's a DDM brand bearing, so we'll say it's close enough to OEM. Got some spacers in here somewhere. Got some piston pins over here. Not sure which one I'm going to use. I'm probably going to get the thicker one since we're running higher compression, huh? Make up for the weight I took out of that piston. I believe they're the same length. Ooh, one's even shorter than the other. Might get a little bit of walkage out of that. I need to measure these and find out which one I need. Crap. Pretty sure it's a small one though. Pretty sure it's a short one because it's a small displacement. Anywho, let's what I like to do. You know what? Let me get my little engine stand out. I'll be right back. Just kidding. I don't know where I put it. In this little squeeze bottle, this is Model 800. It's their road race formula. I don't like to use the off-road formula unless it's like in an off-road vehicle. Reason being is dirt bikes and stuff that are off-road, rolling trails and stuff, don't see the same high RPM abuse that things would when there's pavement. I think we're gonna use this little guy. Let's see which one has a tighter tolerance. I feel a little bit of play in that. Ooh, this one feels good and tight. All right, what I like to do when I'm putting engines together, I like to get one C-clip in one side of the piston first. 2 strokes. Normally have an arrow on the piston that indicates which side of the piston needs to face towards the intake. Some 2 strokes are different. The reason you want your piston to face towards the intake is because you don't take a chance of the rings catching anywhere and grabbing a port and getting ripped. They have little pins in there that keep the rings in place whenever they're inside the engine. So it has to be, it's pretty specific where it goes, towards the intake. Where my C-clips at? Where are the C-clips for the piston? Oh man, I know I threw them in here. I'm back. Little guy had taken off with my little pliers I normally use for this. Oh boy. So what I'm going to do is I'm going to put a piston clip on this side of the piston first. This mounts this way. Intake's on this side, and the reason I want to do that is it might be easier if I lay it this way to get the other clip in versus this way. So we'll take it, flywheel side of the piston, we'll get a clip set in there. Now you don't want your clips, you don't want them to sit perfectly sideways like this with the opening aimed towards the front or the rear, because reciprocating mass will actually cause the clip to to stay in a shrunken position, and it'll come loose. If you look at any 4-strokes or any high-dollar engines, there's always a notch diagonally to catch the clip, and that is so that way you keep it out of that reciprocating problem. And it is windy as heck here because I can hear the bird feeder out there getting the crap blown out of it. Normally I use a little pair of pliers to push these in, but I'm going to see if I can do it with a little tiny screwdriver and my bad eyeballs. So it's in. I'm going to rotate it a little bit. There we go, just like that. I'll double check it. I want to push on it. Make sure she's not going to come out of there. Okay. Go ahead and put the needle bearing back in there. It's already got a little bit of lube on it from earlier. Keep her good and wet. Best thing to do when you're building a motor is try to avoid any metal to metal contact during startup, because sometimes when things start, they start violently, and when they start violently, you want something in there to protect them. All right, I'm gonna try a thick pin, right? Let's try a thick pin. Remember these being this hard to push through the piston. But it has been a while since I built a GoPed motor. Did I even put that in there straight? Are they really that tight now? Holy moly, they're that tight. Jiminy crickets. Don't try to beat yours out with a screwdriver like I am. Oh man. That is crazy how much tighter they are these days. It's almost like they machined it smaller. Machined the piston smaller. Okay, back to what we were doing. Since I'm learning how to put a motor together again. Basically, I'm showing you guys, don't be scared to fucking hit things with a hammer. It's funny, the guy actually taught me how to like build motors and stuff. He wouldn't let me use hammers for a long time because I was a small, frail 13-year-old basically hammering stuff together, not really motors together, but anything together, because I didn't have the strength to really put it together. So we get that in there. It's fully seated. We got a big old gap before the ring. So I don't know if you can see how big that gap is, but it's probably a good 2.5 millimeters from that piston pin. I'm gonna put the longer one in there and see what it looks like, because I want a tight fit there, because I don't want this pin to walk either direction. Which makes me wonder, where did this short pin even come from? Maybe it came out of like an RC motor or something. I don't know. Man, that's a tight fit there, isn't it? I already hear you guys in the comments. I ain't want to watch no damn hammer mechanic. Not a hammer mechanic. Just a dude with some delicate fingers. Give me a break. It actually went in there a little bit easier. Push it. Push it real good. Bam! That looks much better. That gap to the piston clip is much smaller now, and I feel comfortable with that. So we're gonna go with it. We are gonna go with it. My clip. Just like I did the other side, I want to set it halfway in and then push it in the rest of the way with a screwdriver. I don't recommend this on your big block stuff, like gasoline powered vehicles and stuff, because you could scar a piston and really screw some things up. But this is so small and these are so weak that I can get away with it. She's in there, it's seated. Give it a little spin. A little extra. Make sure it's not going to come out of there, because you do not want this thing to fall apart at 13,000 plus RPMs and basically make you eat poop as you drag your face on the concrete. Cylinder base gasket, where we at? Where's all the gaskets at? I'm using all DDM Racing gaskets on this. How does that gasket look? So I think I'm using a set of RC cases. Looks good. I like 1211 everything. 3-bond 1211 liquid gasket sealer. Oh man, it ketchuped me. It's got a little bit of juice in there before we get the product out. And I think I showed this in another video, but this is how I film gaskets. I just put a little bit on my fingers, and then I kind of just smear it to make a clear coat. Like this. I flip it, another smear, 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 and smear, and get your fingers all gross. I forgot to grab Allen wrenches before I started this. Are they still out? Did I put them away? I did. All right, let me get some Allen wrenches. Hang tight. Alright, got my Allen wrenches. Lubricant in the cylinder is always nice upon assembly. Avoid any type of metal to metal contact when you assemble it. You literally can't use too much oil. The worst thing that's going to happen by having too much oil is the shit's going to get all over your fingers. And with it all over your fingers, things might get slippery. Who cares? But literally the worst thing that could happen is excessive smoke during startup. And during startup, things are going to smoke anyway because you're burning heat off of crap. Or you're burning the oils off of everything. So it's fine. Don't worry about it. Make sure you line your rings up. And your cylinder should go on with ease. Line of our base gasket. Cylinder bolts. There is a torque spec for this. I do not know it off the top of my head. I've been highly successful on these little 2-strokes using what's called PFT. Any backyard mechanic knows what that is. It's pretty fucking tight. I do remember this thing being a butt to assemble because of the head. I just remember I forgot to get hardware to actually mount the head to the cylinder. So I'm going to cut this video short today after the cylinder's on. We'll put the flywheel on with the timing advance key and spin it over a few times. I do have a little stand that I bolt the motors to that I can build them on top of, but I don't know where I put it. I really wish I had it right now because it'd make this a little bit easier. It'd be nice if like the hardware that they use was large enough I could just fit my Allen wrench through those holes, but it's not. It's too small. That's pretty tight. That's pretty tight. You know what they say, crank it tight enough till it goes loose, and then back it up a half turn. You should be good to go. All right, so we got that on there. Man, it's a tight motor. It's real tight. Timing advance key. DDM's the rocket key. Just offset. The standard key. Why are we putting a timing key in a high compression motor? Well, we want all the detonation, baby. You don't get no big bangs unless you ignite it soon enough. Or in this case, too soon. That piston in there is so tight. So timing advance key, you want it to go in the direction of operation, which these engines operate clockwise from the flywheel side. So we offset it clockwise on the flywheel side. Slide the flywheel on here. Like so. Little screwdriver in there to get the key to sit right. Where's my flywheel nut? I'm slacking on this video, guys. I'm sorry. bin here just full of archive crap. I can't believe you guys are watching me do this. Ha! Flywheel nut. I need a socket. Damn it. I'm sure there's a torque spec for the flywheel too. PFT is what we're going to use. Heck yeah, we got a little bit of motor together. Oh, she sounds good. That sucker is tight. That sucker is tight. Close off these ports. Add a little bit of lube. Get down there. You get down there. Ooh, make a swell. We go swelling. It gets so tight up top. It's almost like the rings are too tight. But it sounds healthy. I wonder if there's a difference in what they're manufacturing with these rings today versus what they were manufacturing. Because that feels like their rings are starting to hit, like the gap's closing and they're hitting. It sounds good though. Sounds really good. Let's not do that too much. There is no lube in the bottom end. No lubrications in the bottom ends. Alright, so now what we need to do next is I need to get the hardware for the head kit. I am for sure going to run a 16:1 dome on there. We're going to run VP110 with Model 800 at 32:1, 4 ounces per gallon with the Sick Toys pipe. This thing is going to be a little ripper, guys. So yeah, as soon as I get the hardware, the rest of this video will continue. And then the video for me putting this on the little mini bike is going to continue. Oh man, it feels good though. We're getting there. One thing I need to do is after this is built, I'm going to take a 16:1 dome and stick it on there and measure the squish. Because if we look right here at top dead center, I mean that is up there. That is every little bit of the top of that dome of that piston. I mean that is top dead center right there. That piston is out. I don't know if this is going to help or hurt. Maybe it's going to hurt. I don't know. But that's top dead center, and that piston is like... She prairie dogging, boys. Man, that's going to have a hell of a squish. Skadoosh. Kabang. Kabling-a-bang-o. I'm excited. I am going to need full leathers and a helmet when I ride this thing. Alright, stay tuned. And through the wonderful art of video, I was able to run and that thing sounds good. I have hardware for the head kit now. So make sure our surfaces are nice and clean. Make sure this gasket's nice and clean. 16. I think you guys can see it. I know I shouldn't have polished it. It makes everything really hard to see on camera. Drop that in. Oh boy. Oh boy. Put that together. Then we're going to set this on here. Oh boy. Let me get my Allen wrenches and some blue Loctite. I'm going to use blue on these because they are stainless and I do want these to come back out eventually. Because I got a feeling we're going to run this thing, take it apart, and play with it. Grab my Allen wrenches and some Loctite. I'll be right back. Alright, I think what I'm going to do is, oh, it's kind of dirty in there. Well, let's just go ahead and put this on. The dangerous thing with this head kit is that I need a bracket for the coil. Because the coil is only going to be held on by one bolt, which is scary to me. But I believe that's how this thing was before. I'm terrified that this post is going to break off of here and then lock it up, which is what was common with some of the Sick Toy RC head kit engines, if I remember right. Oh man, drop all the hardware in there, Aaron. The joy of stainless. No magnets will ever work for that. Surprisingly, Lowe's had the hardware, which blew me away. I guess they're trying to become more dominant and carrying a lot of this stuff. You really don't need to use broken washers at all. You just really need flat washers. Broken washers have been proven to do literally nothing. There's guys who do torque tests where they torque them to a certain spec for the bolt, then they try to loosen it, and then they torque one without the washer and use just a flat washer. And from what I have seen on the interwebs, is that the amount of torque to loosen it with just a flat washer is exactly the same as a broken washer. I don't know the torque specs for this. It's going to go PFT. They say you tighten it until it goes loose, then you back it up a half turn. Don't do that. Don't be a stupid. I'd say that's tight. What the hell? Now it doesn't move at all. It just hits. It's like the piston is hitting the head. What the fuck? How could I have the wrong? That's an OEM piston. That's bizarre. That's bizarre. Maybe we can't use 16:1. Maybe we have to go to 13:1 because the squish area is too small. The piston physically hits it. Man, I really wanted to run this on 16:1. Boogers. Doesn't look like it hit the dome. Interesting. Maybe it hit the washer. Because it was stopping like here. Maybe we'll pull the cylinder. We'll check the ring gap. File it open a little bit. Because I got a feeling it's the rings. Or it's the RC crank's too tall. Could be one of the many. I don't think the crank's too tall. I'm pretty sure early G230 RC cranks were the same as the LH cranks. Got to use your balls. Yeah, I can't even straighten it up without the ring hitting. Okay. Ring gap needs to be, ooh, Jesus, don't slide out like that, Aaron. This ring gap needs to be opened. Alright, let me grab a file. Hang tight. So we got a little bit of a problem here, guys. I did file the rings, and they don't hit anymore, so we got more free. But whenever I torque the head on, the cylinder shrinks, and then piston bites. And this thing at top dead center, there is zero play in the piston. So I gotta find, well, I did find this. This is a single ring. This is a G2D piston. This is an OEM G2D piston. I'm gonna clean this guy up and put it inside this motor and see if we can get it to work. This piston is manufactured by Husqvarna, and I know that originally the G23LH engine was manufactured by Komatsu. So I think there's a difference in tolerance from this piston to an original piston. And like the original piston, a lot of you LH guys know, had a dimple in the middle of it. This one does not. And I know we're not hitting the head because we're actually binding up at about here. And you can kind of see almost at the top of the port, and we're not even at the top yet. So I'm gonna clean this piston up. We'll stick this piston in here. I'm not going to shave all the crap out of it like I did to this piston. At this point, I want to get this engine to run and hear it run. But for the ring gap, I went on Weissco's website and looked at their high performance stuff. And they say for the application I'm doing of a high compression motor, they say to take your bore, which is 1.257 is the bore, and you multiply that by 0.0055, and then that gives you your top ring gap, which is 0.0069 of an inch. Then your bottom ring, you multiply your bore by 0.0053, and that gives you 0.0066 for the bottom ring. And that's what the rings are filed to, and we're a lot more free this way. But now we're actually physically binding on the piston itself once the head's torqued. I don't have the piston that this thing ran with originally. It might be this one. I don't know. I got so much junk in bins. It's hard to really determine that. So let me get all this stuff switched around and see what happens. Okay, new challenge time. I actually found the piston that used to be in this engine when I originally built it. You can tell by the color of the rings that it's well broken in. They're good and shiny. However, full circle crank with a LH piston. I don't know if you can hear it. The piston is hitting the fucking crank. So I gotta pull this apart, cylinder back off of this, find out where it's hitting and trim it, and hope it doesn't hit when this thing's revving to the moon with all the timing. So, is the timing advance key scary with a head kit? Absolutely. Do I want this thing to blow up while I'm on it? No. So, let me pause this again, and I'm sorry, I would record all this, but I don't want to build a very long video that people just find boring and steer people away from my channel. I want more people to come to my channel and learn as I learn, and kind of see my experiences with this stuff, and hopefully become a positive channel. I don't want people going, oh, these videos are too long. Anyway, shut up. I'm gonna, yeah. Thank God we have the ability to video edit, huh? So I ground out some material in here. It looked like I had like a little dent here and like here on the piston, so I just took the whole area out. Let's beat this back on and see if it hits. Let's hope it doesn't hit, because I want to put this together and give me a reason to measure top speed of that little bike over there. And I really want this video to work. Put this back in. Where's my little hammer at? My little plastic hammer. You guys have a plastic screwdriver hammer at home? I hope you do. With a little bit of luck, she goes right in there. Alright, seated against that pin. The pin's still in there. Oh my God. I trimmed my gasket. I got tired of this thing flopping around everywhere, getting in the way. Just put the clip in, little screwdriver. I'm going to be surprised if anybody actually watches this whole video. If you do watch this whole video, please leave a comment saying you watched the whole video. I found out that 83% of my views are from people that are not subscribed to my channel. So while I'm here complaining about people skipping through my videos, please subscribe to my channel. It's free. Hit the like button. That's also free for you to do. I need my channel to grow. I want YouTube funding so I can build cool projects to put on the internet. It's not loose, is it? Oh. She's in there. Doesn't appear to be loose. Let's try to push it out. Put a hole in my finger. Oh, she's in there. She is in there. Alright. Take 10 of this stupid little motor. Did I put the piston in the right way? I had to have. Yes. Yes. Because I left the pin in, or the clip in one side. Okay. Sorry, I'm just extremely exhausted. Boop. So I cut this gasket. I mean, this looks really thin, doesn't it? And I actually cut it based on the print that was left from this thing getting squeezed by the cylinder and the cases. And that is all that seals the side of the cylinder. Pretty scary. Let's not put that on backwards. Oh, she's in there. Oh, it feels good when it goes in. Get my stupid gasket aligned that I cut. I really just want this thing to be a wing dinger, man. Come on, cylinder alignment, please. Sorry I had to pause that. Little dude ran out in the shop. He's really good about that. I put a new floor in that laundry room and you can't hear footsteps on it, so I have no idea when he's going to show up. And he doesn't need to be in the videos. We got some Motor 800 splooged around in there. But hey, ooh, damn it, we're not hitting. We got the clearance we need now. Let me plug this pulse hole and we can actually hear how this thing sounds crankcase compression wise. Oh, had to cut it short again, guys. Little dude popped back out. I don't have an LH fan cover for this motor, so we're going to use an RC fan cover. It does bolt on just fine. I just want to make sure that the starter will actually reach the flywheel and start it. I'm not sure if it will work that way or not. If not, I'll just take a LH cover off one of the Bigfoots, since both of them are LHs and do have functioning pull starts. This is the fan cover off my Sport, but yeah, we got full rotation now, so ain't nothing to worry about no more as far as things hitting and things getting stuck. This is, again, an original G23LH OEM piston, I believe, when these were manufactured by Komatsu. When the compression is good, I put my finger over the hole and I can't really turn it. So that's good. This thing spins now, and that's what we were trying to achieve to begin with. But with a starter engaged, oh, it will. It will. I don't know if you guys can see it, but no, it's a goofy camera angle. So I'm gonna go ahead and screw this on. Let's see. High output, 29cc. This must have came off of a Chungyang motor. It did. It came off my my GSR Sport that is equipped with a Chungyang. Apparently it's 29cc, so it must be equivalent to a 2-bolt 290. Right. If I'm wrong, you can tell me. I won't cry in public. All right, I'm gonna put this coil on here and put a carbon stuff on. That's all easy. It's a couple bolts, and we'll film the top speed run of the little bike and see what it does, and then we'll go ahead and fit this motor onto the little bike and a pipe and see what it does. See you guys in a little bit. So I am going to record the final touches to this motor only because I can put this in a whole other video, and I'm going to do that just for you guys. All right, coil is on. It is gapped. We have one coil bolt because, well, there's nowhere to mount another coil bolt. Maybe in the future I can machine one of these heads, or like make an adapter that I can bolt to the head with an offset that I can bolt to this. I don't know. I gotta figure that out. I don't know. I got the manifold on there. I'm getting ready to put the carb on it as soon as I can find my 1211. I lost. I dropped it. I'm gonna run, since this thing's ported, I think it was like a 517 or something is the traditional HP carb for LH motors. I'm not gonna run that. I'm gonna run a 668 because this thing's ported, and the 668 seems to be a phenomenal carburetor in other applications of mine. And I pulled the choke, plugged the holes, and it's horny. Oh shit. Got some splooge on it. Sorry, ain't gonna hurt nothing. Man, this thing doesn't smell like Mountain Dew when it's running, then I did something wrong. I mean, how cool is this thing gonna look with a horn on it? That little bike. Oh man. I think these horns are freaking sweet. I do need to get a velocity stack, an air filter. Well, I do have a velocity stack. I just don't have an air filter. You know what they say? Tighten it till it feels like it's loose, and then back it out a quarter of a turn. Oh man, this thing's gonna make somebody horny. Look how cool that looks. A big old horn on it. It's got some good flow in there too. Although I forgot to put the swivel and the bracket on. I can do that though while it's mounted. I just wanted to get that on for you guys. I was very fortunate. Lowe's happens to carry hardware for these, or metric hardware now. So it's very easy to find everything we need. I'm missing a fan cover piece here to put these things together now. The only thing I haven't been able to find is the actual engine mount screws. Bigfoot application, you can use Allen bolts and stuff because you have the clearance, but other spindle driven stuff like sports, you got to be able to clear the tire. And since this is going to have a bead lock on it, we need all the clearance we can get. So there's that. And I like having these Allens for the engine cover because you can just guarantee they're tight versus using a silly Phillips like they used to sell them in the past with. Oh man. Of course, there's a grommet for the factory cover that we're not using. There it is. I remember with these, you got to trim the bottom of this for the pipe adapters because of the way the springs line up. They actually hit, and they makes the spring sit all goofy. So I end up trimming these a little bit for a pipe. But yeah, this thing's gonna be gnarly. Oh my god. Jesus. That thing. Should I put diesel in this? No, that'd be a bad idea. Some compression. All right. There it is, the G23LH head kit. With a 668. And she's horny, baby. She's ready to go. Cool. All right, I'm done.